بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. So this is lecture 5 of the course about IoT application development, and in the previous lectures we have introduced the IoT architecture starting from the sensors to the networking layer, communication layer, middleware, cloud, talked about different technologies, Industry 4.0, cyber physical systems, machine-to-machine communication, and so on. And starting from today, we're going to dive deeper into the different components, starting from the hardware aspects of an IoT ecosystem. And basically, we start from the sensor devices themselves. And sensor devices, they are composed of course, sensors, which collect data from the internet. But also these sensors, they need to work on particular type of boards, okay, like small computers. And these computers are known as embedded devices. So during this week, lecture 5 and lecture 6, I'm going to introduce the most fundamental concepts about embedded devices, which constitute the computing platform for a sensor node in general. So we're going to be covering the embedded devices in IoT and focusing on Arduino and Raspberry Pi. There are so many others, but these are the most known two platforms for prototyping and for educational purposes. Of course, they are not at commercial level, but they allow you to do everything possible with commercial level. Of course, commercial level platforms are just more expensive with more reliable components. This is the main difference, but the workflow is basically the same. Okay, so we'll introduce microcontrollers, and you will see the difference what is between microcontrollers and microprocessors, their architecture, power management, how to do power management with embedded devices, what are the available communication protocols like serial communication, SPI, and also how to program with Arduino and IDE with either in C language or in Python, depending on whether you use Arduino or Raspberry Pi. Okay. So at the end of the lecture, you will learn what is an embedded device architecture. So you'll be able to understand the key components, like what is a GPIO, what is an analog to digital converter, ADC, CPU, processor, and memory, different type of memory, the RAM, the ROM, and so on. The difference between a microcontroller and a microprocessor, differentiate between both, and also how to do basic programming. We're going to have a whole week about programming these devices, but I'm going to give you a sample code just to get a feeling about it. And also we'll introduce the communication protocols, how we can interface with these devices either wirelessly or using wires. So I don't know whether you had a computer architecture course before on the architecture of computer components, so there is a lot of sharing here, but it's going to be more focused about the characteristics of embedded devices. So first of all, what is an embedded device? So embedded devices are boards similar to this one. So basically, this is the most basic embedded device you can have. It's Arduino Uno. And as you can see, it has different type of components. You want to understand what are these components and what is their function. So these embedded devices are built-in, purpose-built-in systems combining hardware and software to perform dedicated functions with real-time constraints. Of course, they will deal with sensing, with actuation, with IoT. We have talked about IoT ecosystem, and several applications would have real-time constraints. The core components, so basically they will have microcontroller units, or what we call MCU, which handle the control tasks like in Arduino. They can be connected to sensor devices. So there are different type of serial connections on how we connect sensor devices or actuators to these boards. Can be sensors or actuators to respond to processed data. And also we have communication modules. Okay, so one of the communication modules, for example, is the USB port that everybody knows. So this is a communication module. You can connect a computer here. You can connect another device to get information or to send information through this communication module. This is wired. You can have Ethernet also. This board doesn't have an Ethernet, but we can make extensions to it to connect it to the internet. And you can have also wireless communication modules. Okay, wireless communication module if you want to communicate through Wi-Fi, through Bluetooth, or through LoRa communication. And several of these devices, they have real-time requirements because maybe they work in the context of smart manufacturing or Industry 4.0, where we have discussed a lot of real-time challenges. There are hard real-time and soft real-time requirements for this type of devices. And real-time operation will require to provide deterministic execution. And what does it mean, real-time constraints? The success of a task will not only depend on its completion, but it depends on when it is completed. It has to be completed within a certain amount of time. Okay, for example, if you have an alert for a fire, you cannot wait an hour to respond. You have to respond immediately. Okay, if you have a heart pacemaker that provides you an emergency information, it has to act immediately. So real-time constraints are very important part in several IoT applications, and embedded devices are designed to support these type of constraints. So there are known type of platforms, and this is a slide that give you some examples, like Arduino, the board that I have here in my hand. So this is of type microcontroller, and I will explain the difference just in a moment. And it has this microcontroller at Mega 328. It operates at low clock speed. It means it's not very fast. And this is the memory. This is the memory characteristics. It has very small memory of 2 kilobyte only as a static RAM, and 32 kilobit of flash memory. So don't worry about this technology. We're going to go on every single detail. What is an SRAM? What are the different types of memories? And so on. This is just to show you sample of characteristics. The GPIO are the pins. It's input, output, general purpose input, output, which are pins similar to these ones. Okay, as you can see here, this can be considered as GPIOs. Okay, through which we can connect devices, sensors, for example. Okay, like you want to connect a temperature sensor or humidity sensor or an LED to control it and so on. And the power, of course, they will take power either through a battery or through mains powered. Okay, and usually they operate at 5 volt or 3.3 volts. So Raspberry Pi, it's more powerful. This is what we call a microprocessor, not a microcontroller. It has the microprocessor type ARM Cortex A72. It can run an operating system. Okay, so this type of devices, they don't run an operating system. We just put a firmware inside a very small memory component that we call EEPROM. But these ones, they are like mini computers, like your computer. You can install Linux operating system, or there is also a Raspberry operating system earlier back in the days for Raspberry Pi, but now the current version of Raspberry Pi, they are powerful enough to work a Linux operating system, like Ubuntu, for example, or Red Hat. They have also GPIO pins to get signals from sensors. And they are more sophisticated. They can have even AI capabilities, so they can play videos at 4K, especially with Raspberry Pi 5, the latest version of Raspberry Pi. And we can have some more dedicated modules. This is also another type of an embedded device. It's in between these two devices. So this is called ESP32. And this device is made for wireless communication, basically through Wi-Fi or Bluetooth. So it's a built-in board to allow Wi-Fi communication. So this module, it just allows to send through Wi-Fi or connect to the device through Bluetooth. It doesn't have very sophisticated capabilities like this one. You won't find like memory or so on. It's just an intermediate device to send information back and forth. It has also serial interfaces like I2C, UART, PWM. We'll explain all the different things, but this is ideal for wireless IoT applications. So these are just few examples about what could be an embedded device. So let's talk about the architecture and types of embedded devices. So this is the general architecture, which also applies to this Arduino Uno. So basically, we will have a processor, small processor, which is this component here. Okay, this is a processor, very small. Okay, and usually we can connect directly to this processor through a JTAG interface for debugging. This processor is connected to input-output components, like it can be a USB, like this one. It can be an I2C, like this different type of ports here. We call them I2C devices or ports. We can have SPI, which is faster than I2C. It allows to connect, for example, external SSD drives. And we can have UART, which are serial devices that allows to have transmission and receival of data. So we can have also a memory where to store temporary variables. If you do programming, you have some variables that you will define for different type of sensors. Okay, so this is what we call the RAM, or it can be a static RAM, and static RAM is fast, but it has also some other limitations. And we can have a cache, which is usually memory related to the processor for faster execution. And it can have also a flash memory, which is a component where to upload the firmware of the microcontroller. So this is the general architecture of embedded devices. We can have also pins, which we call them general purpose input and output pins with the GPIO controller, through which we can connect also different types of devices. And the processor, it will be attached to a clock that will tell us about the speed of the processor. Of course, now for example in Arduino we have only 16 megahertz of clock speed, which is very low. Now typical computers like Raspberry Pi, it operates at 2.4 gigahertz. So you can compare 16 megahertz to 2.4 gigahertz. It's a big difference. Okay, but you know, these type of devices, if you have only very small amount of data to process, you don't need to purchase $130 device to process small information, while you can do it on $5 device. So the cost plays an important role, because if you will deploy this in scale, you cannot just buy the most expensive hardware just because you want to have an unnecessary processing features. Okay. Any question?
Doctor?
Yeah.
This piece is Arduino, right?
Yeah, this is Arduino. Yes. Yeah.
What is the difference between the communication ports and the GPIO?
Okay, yes, good question. So the GPIO basically, like these inputs,
Okay.
it's used to connect other devices like sensors. Yes, communication ports like serial, you can connect other devices, but it's more general. It can be Wi-Fi also. Okay, they have different type of characteristics, different type of shapes to connect other devices. Like if you want to connect a laser with USB, you can use this port, because a USB is faster than this GPIO pins. So GPIO usually for low data rate sensors, like temperature sensor or so on.
Basic things.
Yeah, basic things.
And the communication port is for
Yes.
specialized things.
Yes. So all these communication ports allows you also to connect other type of devices to get data out of them. And depending on the type of interface of that device, you will use one of these ports, whether GPIO, or you can use some of these communication ports based on the need. For example, if you want to connect an SSD hard drive, which is a fast type of storage, you cannot connect it on the GPIO. First of all, there is no interfacing with the GPIO. It can be connected maybe through the USB, but you know, if it is USB 2, it will be slow. And there are other type of device like SPI, where it can be connected and provide much higher bandwidth and data rates for exchanging the data between the board and the SSD hard drive. Voila. Other questions? Okay. Okay, now this is a very important slide. The difference between a microcontroller and a microprocessor. So let's say that a microcontroller, it's built for small tasks, very simple tasks, okay? Doesn't require too much computing resources. And the microprocessor, it's built for more complicated type of processing, which requires additional resources. This is just talking non-technically about this. Now, technically speaking, the microcontroller is an integrated circuit for an embedded system task. So it's basically, we will define very simple tasks because usually it doesn't have high processing speed. It doesn't have abundant resources to perform very critical tasks. And Arduino is one of the examples, as we discussed earlier. But they still have processor. They will have a processor. And there are other type of Arduino devices that will have higher memory, higher processor. So for example, this is only 32 kilobyte. If you have a program that is large, it will not fit into an Arduino Uno. So you can buy another board that is Arduino Mega. You know, instead of 32 kilobytes, it will provide you 256 kilobytes. Still small, but it can fit bigger type of programs depending on the scale of your processing. And it has a memory. It has input output into a single chip. A single chip integrates all these different devices, and it's optimized for real-time control and low power consumption. Okay, but it has limited computational power, usually over 8 and 32 bits. So this type of microcontrollers, we connect them directly to a particular device. مثلا في robotics. Robots usually they have motors, okay, and we need to control these motors to provide them the speed. مثلا عندي right motor and left motor, and both of them I need to control their speed. مثلا في robotics حتى الروبوت يتحرك أمام لازم right wheel and the left wheel both they must have the same speed. So we can have a controller like an Arduino device that will send the velocity to the right wheel and the left wheel to make it move. So if I want to make it forward, I will tell this microcontroller to send the same speed to the left wheel and the right wheel. Now, if I want to rotate left or right, so for example, the speed to the left must be higher and speed to the right must be smaller. In this case, it will rotate to the right and so on. So this is what we call a control. These type of devices are very good because they provide hardware interfaces to connect special hardware to it and to define a control protocol. So I can communicate in real time, this is why I told real time, with robots by controlling the speed of the motors. So from where it comes the speed of the motor? It will come from a high-level application. And usually this high-level application, they will require more resources, and in this case we use microprocessors. So in robotic application, we typically have a microprocessor to interface with users. For example, the user would say, I would like to move 2 meters per second in the straight direction. Okay? So we will provide the velocity, the microprocessor level, and then it will come to the microcontroller, which is attached directly to the hardware. And from there, we will convert the speed, the velocity that is sent, to a signal to the right motor and a signal to the left motor. So this will do a very particular task, which is the control of the hardware. And this allows to perform more complicated tasks, like, for example, defining a complete application logic for the robotics, for example, to navigate in space, to avoid obstacles, to make self-driving cars, depending on the type of application. So the microprocessor, at the end, it has a CPU, an advanced CPU, which is a processor for complex computing and operating systems. And Raspberry Pi is one of the boards. Of course, it has limitation, but in many applications, it allows to perform advanced computing with this Broadcom PCM 2711 type of chip. And the key features, it requires an external memory. So this has a built-in components, memory with RAM, with everything, so built-in on the board. This one will have an external memory with peripherals, high computing power, so 64 bits multi-core CPU, okay, to allow the processing of a complete operating system. So you can install a full operating system. You can perform multitasking, whereas here in microcontroller, you can only execute a single task. This is why this type of devices, microcontrollers, are very specific to do only one category of operation. They are not meant to do multi-threading or multitasking, many tasks at a time. They cannot do that. they are very specific. Okay, their task is very specific. Okay, so microprocessor, we can make video processing, we can do AI inference, IT gateway management, and even a whole smart home edge computing. So we can use it for edge processing. It can do advanced computation. Is it clear, the difference between both? واضح الفرق؟ Yes, no? Okay. No response means everything is fine. Okay, so this is a summary table. Okay, so microcontroller architecture-wise, it has everything integrated, CPU plus RAM plus flash to make the computation faster. Okay, لكن هنا it has CPU only and needs extra RAM and flash to operate like a microprocessor. Power consumption. Okay, power consumption, this is low, and this could be moderate to high. Even Raspberry Pi مثلا انتقلت على مراحل، كانت تشتغل على 5 فولت اصبحت 7 فولت الان توصل الى 19 فولت requirement 19 volt. Okay, so even the power usage depend on what is the complexity of the task that we need to run. Okay, we cannot run, for example, AI algorithm on a low power device, or only if we make it very simple. Okay, so we lose accuracy in this case. So the operating system, a microcontroller doesn't have an operating system. It has a bare metal programming. So usually we upload a very basic program that you call a firmware, which is a C program. نعرف أنه C, it's a low-level language. So C, it's used to program hardware devices directly. Okay, because it's easily converted into a binary code. Like with microprocessor, we can use advanced programming languages like Python or maybe Java or other programming languages because they operate on a full operating system. And microcontrollers are designed for real-time control. I gave you the example of controlling the motor speed of a robot, for example, and can be used in other type of cases. But microprocessor, they can do real-time to some extent, but they are not designed for this type of situation. Of course, now if we talk about multimedia application like video processing, yes, microprocessor, they can process real-time video in real time because they have GPU. Now, Raspberry Pi, it even comes from a GPU that allows the processing of 4K video stream at 60 frames per second, okay, which is not possible with microcontrollers. So let's look again deeper at Arduino Uno components. So this is exactly the same as the board that I have. This is a USB plug. This is a reset button, which is this one. This is the microcontroller, this small device here. This is an external power supply. Usually you can use your phone charger with 5 volts input to provide a power supply to the Arduino board. You have power pins. Okay, so when you connect a sensor device, it requires to have power. Okay, so usually we can use these pins in order to provide power supply to sensor devices. And the analog input. So there are different type of signals. The analog signal with digital signal. Some of the sensors, they will provide you analog signal, continuous. Okay, so if you have analog sensor, you will need to plug them into these ports. كيف تعرف؟ لما تشتري sensor, when you buy the sensor, it will tell you whether this sensor is analog or digital. And based on this, you will choose either the analog input or digital input. Look, here we have digital input and output. All these inputs are for digital type of sensors or digital devices. If you have an analog device, you need to connect it here. Why? So this device will provide an analog signal, but internally in the code, you will be able to process digital information. So you need to convert this signal from digital into from analog into digital. And this is why we should have special hardware here that is called analog to digital converter, ADC. okay, that will convert the analog signal into a digital signal, and later on you can process the information into your code. Okay, so this is basically the main components of an Arduino Uno board. And you can see the very low specification of the board. The architecture is only 8-bit RISC architecture for the processor. Clock speed only 16 megahertz for efficient processing of instruction. Of course, only for processing small, only small amount of data coming from the sensors. The flash memory is 32 kilobyte for storing program code. So when you write a program, it will be stored into the flash memory, okay? And the maximum size of a program is only 32 kilobyte. This is the SRAM for runtime variable, and the EEPROM, this is for persistent data storage. So the Arduino also has what we call GPIO, which are this input and outputs. Okay, it has 14 pins, 6 PWM pulse width modulation. I will be talking about this in detail later in tomorrow's lecture. Okay, and usually this provides a power supply that is non-constant. I mean, it can be on and off. And based on this, we can control the speed of the motors and also the brightness control. So I will keep the details for tomorrow's lecture. Now let's understand the overall layout of the GPIO pins. And as already mentioned, we have analog input pins, which require an analog to digital converter for converting the signals that comes from the sensors into something that can be executed by the program. And these are of different type of inputs, UART, which are serial communication, and SPI, the pins 10 to 13, and we have I2C, which are the pin A4 and A5. So every type of device will require a particular type of data communication with the board. So for, yes?
For the Arduino, the processor understands in 0 or in digital?
Yes, everything in processing must be digital.
So why we convert from analog to digital? Why we just directly convert from analog to 0?
Yeah, digital is 0 and 1. This is what we call digital.
Well, it's not the whole.
Yeah. So you have a continuous signal, which is analog, and there is an ADC that will convert it to a series of ones and zeros, what the machine would understand. Okay, different. Now, it's basically there are different levels. Because there is a quantization from 0 to 1023, okay? And this level will give some particular values, for example, for the temperature. Okay, for the temperature, you can have a range of temperature. How can you differentiate between them? It will be encoded into values between 0 and 1023. And then we'll convert this value to the correct temperature that comes from the sensor. Okay, so the ADC controller, the ADC will convert the signal into a value between 0 and 1023, which is like a value that will tell us about the temperature or the humidity that comes from level that comes from the sensor.
So how the processor understands?
Yeah, this depends on the specification of the sensor. Okay. It will tell you which level corresponds to which value. Yes, there is usually a conversion. Yes, we need to do a conversion from 0 to 1024 into the correct range of, because every sensor will have a data range. For example, if you have a range sensor, maybe it can measure between 10 centimeters and 4 meters. Beyond, so when you receive a value between 0 and 123, it will be mapped to a range between 20 centimeters and 4 meters. Depending on the sensor specification. Okay? So look at the Raspberry Pi. It has more powerful capabilities. 64 bits, okay? And operates at 2.4 gigahertz instead of 16 megahertz. So you can see the difference in scale, which delivers significant performance improvement over the Raspberry Pi 4. Raspberry Pi 4 was operating at 1.8 gigahertz. Okay, so this is much more powerful, and it comes through different memory options. So when you buy a Raspberry Pi, you can buy it at 4 gigabyte of RAM, 8, or even 16. You know, it's equivalent to the RAM in my laptop, sophisticated laptop. Okay, and it has an LPDDR. I will explain the type of memory later, for enhanced multitasking. So we can use multi-threading. So it means I can run multiple processes at the same time inside a Raspberry Pi. Storage. So we can use a micro SD card, for example, 128 gigabyte, and you can even store it at 1 terabyte. Okay, you just need to plug an SD card to store your personal data. And you can even add an SSD hard drive if you want to make a faster storage. Okay, with some configuration, you can plug an SSD hard drive through the PCI interface for high-speed data access. And the added value of Raspberry Pi over the previous ones is that it has an integrated GPU along with the CPU into this system on chip. Okay, it has a SoC integration which combines both a CPU and a GPU. But of course, this GPU is not as the same GPUs that before for gaming. It can improve, for example, the video execution performance, but it could be limited for AI algorithms. For example, if you want to make YOLO algorithms or object detection, it can work. It will provide better performance, but still it's not at the level of non-edge devices. Okay, so, but this represents a very powerful platform for IoT applications to perform even AI algorithms inside or video processing. It can work. So for example, in one of the AI applications that we developed, we use the Jetson boards. So there are other boards that are more powerful from NVIDIA, Jetson Nano, which comes from NVIDIA GPUs. So these are much more powerful, but of course they will require more power to compute more deep learning algorithms.
Can we overclock the clock speed?
Yes, there are options. There are options on how you can overclock the CPU of a Raspberry Pi, but of course it will be at the expense of higher power consumption.
So this number is the maximum number or the most optimal number?
No, this is like the nominal number. I think it can go up to 3.2 gigahertz. Okay, it can be overclocked to 3.2. But of course, if you do that in battery powered, it may dissipate your energy. But if you do it on mains powered, it provides sufficient power requirement. Yes, you can do it. So yeah, and this is powerful. But sometimes, for example, if you want to plug a power greedy device like a laser or a 3D LiDAR, maybe it cannot work on these type of devices. So one time I had a robot with a Raspberry Pi, and I wanted to attach a depth camera. So depth camera, it gives you both the RGB camera and also the depth, which is the distance of the object in the picture. So it's a 3D. So the power requirement of the depth camera, I think it was around maybe 19 volts or something much bigger, because I was connected it through the USB. USB can only provide, it was a Raspberry Pi 3 at that time. I think it provides only 5 volts. And the power requirement of the device was even much higher than 5 volts. So it was just failing when I wanted to connect the sensor to the board. So it's really very important when you buy a sensor you want to connect to any board is to understand the power requirement. Okay, because usually this USB is going to provide you some power, and it has to be matching the power requirement of the device that you will be connecting to your embedded system. So these are the specifications of the GPU, which is located in the system on chip here of the Raspberry Pi 5. It's a Video Core 7 for the next generation hardware accelerated graphics and video. It supports dual 4K at 60 frames per second. This is huge. Okay, 4K at 60 frames per second. video output via the HDMI display port. So it has an HDMI display. You can connect it to a screen and can give you 4K video in your display port. And it has also connectivity, advanced connectivity. You can connect through the Ethernet to a local network at 2.5 gigabyte for high-speed wired networking. It can connect to Wi-Fi 6 for faster and more reliable wireless communication, and also you can connect it through Bluetooth 5.2 for improved low energy communication. So you have different options on how you can communicate to your device. Okay, so microprocessor example, here the GPIO interface, similar to Arduino. We have also another interface which we call GPIO. Tomorrow we'll have more complete information about this. But this provides a way on how to provide inputs from sensors or from other type of devices. And you can see these are numbered, okay? And you can control these devices using Python. Arduino uses C language, which is a low-level language, to upload into the firmware. And Raspberry Pi, it's a microprocessor. You can use Python. So there is Python GPIO library that you can import. And then you can have access to these ports, whether in input or output, using Python programming language through these numbers. Okay, so every number, for example, this corresponds to a power supply of 3 volts. Same thing here. Okay, this is an I2C port. This is a power port. This is an SPI port. So this is another type of interfacing. So not all these ports are the same. And usually when we work with embedded devices, you have to look at the data sheet. What does correspond to each port? It's not just plugging a wire here. You can just burn it out. You can burn your sensors or provide the wrong input or the output. So it's really important to have a full understanding, because, you know, software engineers usually don't care about this stuff. So they just plug their things, go to the coding, and then they just burn everything out. There is a data sheet with every control board that you need to understand at low level. Okay, and it even has a thermal management. Usually when you run sophisticated application like AI or deep learning, the board will be heating. So we can attach a heat sink that will يمتص all the heat that will come out of the board. If you don't do that, you can damage your component. So when you have a very complex application that will run on the board, it's better to have a heat sink, okay, for active cooling and high performance. So usually it comes with a fan to keep the board always cooling. Usually this board will have very much lower performance if they become very hot. Okay.
Is it the CPU cooler?
Yes. So usually we put it على ال CPU. Okay, that contains هو غالبا الهيت يكون من الجي بي يو. الجي بي يو it has more heat. ذلك الآن في الجيمنج بي سيز في حتى الواتر كولينج الآن. If you buy a gaming PC, الفان كولينج ما عاد كافي، فيكون هناك water cooling to maintain a certain temperature, okay, for the GPU. Otherwise it will degrade in performance. وتشوفوا مثلا الايفون لو تخليه في 40 درجة خلاص it doesn't work anymore, okay, because of the heat effect. Okay, so this is a picture that shows how we can plug an external SSD hard drive, يمكن يكون 128 or 56, depends on how you want, through the
PCI.
non-volatile, yes, PCIe, non-volatile memory express, okay, which provide a high-performance protocol designed specifically for accessing SSDs. Okay, and in this case, you can have a fast access, storing your data much faster than if you use an SD card. SD cards are usually very, very slow. Okay, وفي بعض الأحيان they actually hack the installation of Raspberry Pi or Linux. Instead of doing it on SD card, they will do it on the SSD, and this will provide much faster execution.
هذا ال M.2 صح؟
نعم. If you want to have a high performance with Raspberry Pi, it's recommended to install an external SSD hard drive and then install Ubuntu there. Otherwise, it will be malfunctioning. You know, SD card is not is not sufficient for running real-time applications on Raspberry Pi. Okay, and this will allow AI acceleration and also more energy efficient, smart power saving modes help to use less energy while still performing very well. So this is a summary between Raspberry Pi 4B and Raspberry Pi 5. So we can see there is a difference in the type of chip here. It works on, this works on Cortex A72, here 76. And you can see the difference. Both they work on 64 bits, but the clock is different. Here it's 1.8 gigahertz compared to 2.5 gigahertz. So in terms of GPU, there is also an improvement. This runs only at 500 megahertz, and Raspberry Pi it runs at 800 megahertz video core 7 GPU, which supports OpenGL, which is an open source library for 3D rendering, okay, and other libraries as well. So for the memory, Raspberry Pi 4 only has the maximum memory of 8 gigabyte, and now you can store at 16 gigabyte in Raspberry Pi 5 with different also memory model. For the storage, only supports micro SD card slot, and Raspberry Pi also introduced the possibility of adding an SSD. You know, these are tremendous changes, okay? Because if you want to work on advanced application like AI, this is hardly usable. So we need to optimize the performance of storage. You know, the read and write access to the hard drive. وتشوفوا انتم مثلا الأجهزة القديمة في وقت من الأوقات يصبح الريد على الهارد درايف very slow. الآن مع الاس اس دي تغير الأمر. But the quality of SSD also depends. Okay, old versions of laptop اللي يشتغلوا على الويندوز وعلى ال HDD drives يعني بعد سنة سنتين they becomes always useless because the performance degradation of the hard drive make it very difficult to write your data. If you have a large file to write on your computer, it will spend a lot of time. Okay, several seconds or several minutes just to write one file because of the slow access to the external hard drive. And look at the difference also. Because of these upgrades, it has a consequence on the power consumption. Okay, so it's really hard to operate Raspberry Pi on batteries, unless if it is a large battery. But here it will consume 7.5 watt, and here it will consume 15 watt. This is almost close to a laptop. You know, a laptop usually they works no, laptop is much more. And you know, with this power also, it has an advantage because you can connect more power greedy devices. Okay, ممكن مثلا some advanced lasers you cannot connect them into Raspberry Pi 4, but you can connect them into Raspberry Pi 5 because the ability of providing more power. Okay, any question? So now, at the end of in the remaining part of the lecture, I will talk at three main components of embedded devices, which is the CPU, the RAM, and the ROM, and difference between them. So CPUs are a core component in embedded devices. We can find them both in microcontrollers and microprocessors. And the CPU in a microcontroller is designed for dedicated tasks with low power consumption and real-time performance, as already discussed. But here it's designed for more high-performance general-purpose computing. And design-wise, they are completely different. فهذم غالبا يكونوا slow clock speed, but for very dedicated type of tasks to run in real-time control. هذم it's more general-purpose. They are closer to what we know as laptop desktops nowadays. So comparing the key features, so this works at 8-bit. It can work at 8 bits, 16 bits, 32 bits. It's how much memory will represent data. Okay, for small microcontroller, it can only represent data at 8 bits, which give us 256 type of configuration, and they can go up to 32 bits, like at Mega 328. In Arduino Uno only works on 8 bits. However, in Raspberry Pi, the lowest is 32 bits and the highest is 64 bits. okay, which is typical for the A76 CPU that we find in Arduino, in Raspberry Pi 5. We discussed about the clock speed also, big difference, 16 megahertz to 2.4 megahertz. So this is approaching the performance of CPUs in commodity desktop and laptops. The execution type here is only made for single-threaded, very specific type of tasks, whereas here it's for multi-threading and support for advanced features like caches and pipeline for faster performance. Okay, so the type of application for CPUs in microcontrollers to control sensors, actuators in real time, whereas here it's suitable for more general purpose applications like video processing, AI, IoT gateways, and multitasking environment. And this table just make the difference between both. So the second component is the RAM. So what is the RAM? What is the purpose of the RAM?
To store temporary information.
Temporary information. Why it's temporary?
Because it's faster.
No. What is the main characteristic of RAM? RAM في الكمبيوتر. To store temporary information, that's correct. But why it is temporary? Why it is not persistent? No, it has a high storage. You can have 32 gigabyte of storage, 128 of RAM in nowadays computers. Because when you turn off the computer, you lose everything. Okay? It's not persistent. It's volatile. Okay? So this type of memory is volatile memory because it's used to store data in the CPU that we need during operation. And this is when you develop a program and you execute a Python script or a Java program, everything will be running in the memory. If the computer crashes or you stop it, you lose everything. You need to start everything from the start. Okay? So it's volatile memory that we use to store data during the execution of programs in the CPU. So the data is erased when the device is powered off and used for storing variables during program execution and temporary buffers for data transfer or processing. ممكن نستعملهم في communication أيضا. Okay, we store data in the buffer and then we transfer them to another device. So there are different types. والناس اللي مغرمة بشراء الكمبيوترات يفرقوا بين different type of RAMs. Okay, البرو الآن في الجيمنج يبدأ يقول لك هذه نوعية الرام كذا هذه كذا لأنه فيه big difference in terms of performance. The first type of RAM اللي هو called static RAM. Okay, and it's called static because it does not require refreshing data. التقنية مبنية على الفليب فلوبس اللي هم 6 transistor to store 1 bit. Okay, so we use 6 transistor to store 1 bit. So this technology has low latency, يعني it's very fast memory. لكن what's the issue? The issue is that I need 6 transistors to store 1 bit. So the memory is going to be very huge in terms of size because of this number of transistors. Okay? But it has high power efficiency because it doesn't require to have refresh cycles. So it doesn't dissipate energy. And it becomes in low density. Yani the cell size to store 1 bit of memory is large and also expensive. فلذلك هذوما الآن نستعملوهم فقط لما نكون عندنا memory with only very small storage requirement. نستعملوها في الكاش مثلا. الكاش اللي يكون جنب البروسيسور معناها very low latency we can access. الكاش تعرفوه انه يقول لك لما يكون الكاش كبير تكون العملية أسرع لأنه جنب البروسيسور. So usually it will be a fast exchange between the processor and the memory. And microcontrollers 2 kilobyte, very small. So this usually they come in SRAM type of memory. لكن الآن if you want to make devices with 16 gigabyte, 8 gigabyte, 100 gigabyte, this type of memory will fail because you will need large size memory in this case, and you want to have a compact size. So in this case, there is the other type which is called dynamic RAM. And here, the storage technology is different. It uses 1 transistor and 1 capacitor instead of 6 transistors. طبعا this is electronic design wise. So this makes the size more compact, but it's dynamic. Why? It comes with a drawback. الكاباسيتر هذا it will leak energy. أنت تحب تعمل فيه بيت 1 يمكن الكاباسيتر يضيع energy يولي ماشي يعرف 1 ولا 0. فit requires refresh cycle. And this refresh cycle will dissipate more energy, so it will have higher power consumption because of this refresh rate. It's dynamic. It will require to make dynamic refreshing, so it will dissipate more energy, but it will have higher density. معناها in a small chip I can have larger storage. Okay, and this is why now what you find in the market in the RAM, all of them are dynamic RAM. Okay, static RAM نلقاها مثلا في microcontrollers, only small storage requirement. لكن in high storage requirement usually there are DRAMs, okay, and they have slower access, 500 to 100 nanosecond due to the refresh cycle. Okay, so the DRAM has made several improvements over time. The SDRAM, which is synchronous here, instead of sending bit by bit, it will collect them on what we call multiple words and send them in batches, in bursts. So this will improve the efficiency. Okay, improve the efficiency because it will be synchronous and will have better efficiency as it synchronizes the data transfer with the system clock instead of sending every bit together. So it will make synchronization here. Now another evolution is the DDR, which is the double data rate. Instead of sending on one direction, it will have bidirectional flow. So here it will provide the doubling of the bandwidth ما بين الCPU to let back and forth, okay, at the same time. And there was multiple generation DDR at 2.5, 1.8 DDR2, DDR3 and 1.5, and 1.4 for DDR4 and 1.1 for DDR5. So here it means they have made low power consumption. وذلك علاش استطاعوا يدخلون في smartphones. طبعا smartphones they have different categories, but this power consumption is a very important aspect of the RAM. So it, especially in embedded devices, so it can maintain the energy. And we have also LPDDR, which is the low power DDR, which we found in tablets, smartphones. Okay, they operate at 1.1 volt. So LPDDR4, okay, this is operates at 1.5 volts and retain high speed performance. هذا بالآن موجودين في smartphones to avoid dissipating a lot of energy. So this is a table that compare the different type of RAMs. So SRAM is the fastest, but it has low power consumption, high cost, and only used in microcontrollers and cache. Dynamic RAM, okay, it can go from moderate speed to high speed. Okay, it usually has high power consumption. Now with low power DDR, it has reduced the power consumption issue with the evolution of the different types. And the cost is, this is high and this is moderate. And here you can find the different type of application of the different type of RAMs. So as already explained, why the DRAM is the standard now in computers, despite that the SRAM is being faster. As already mentioned, the cost, okay, because 6 transistors per bit will make it significantly more expensive to manufacture. Okay, and the DRAM uses only 1 transistor and 1 capacitor, while the SRAM, it uses 6 transistors to store 1 bit. So for large scale memory requirement like 8 gigabytes, 16 gigabytes, and even more, DRAM is the more cost effective. The other thing is the density, okay, because the SRAM will have a larger cell size. Okay, it cannot come into a compact size, and in modern application require large amount of memory, and DRAM can provide this more efficiently because their size will become more effective. Performance trade-off. So SRAM, it has an access of 10 nanosecond, whereas the DRAM, it can go from 50 to 100 nanosecond. And power consumption. So SRAM is the lowest, but with the evolution of DRAM, now with low power DRAM, we can also control the voltage at 1.1 volt only, which provide lower power consumption. Okay, so these all are summaries. You can even. So the last part of this lecture is about the read-only memory requirement in embedded devices. So what's the difference between a ROM and RAM? حتى الROM موجودة في الكمبيوترات. What's the difference?
الرام نسوي ريد ورايت وهذا بس نسوي ريد.
Read only, yes. And another aspect. الROM is non-volatile, it's persistent. هي تخليك تشغل الكمبيوتر. Okay, it's always persistent. So the read-only memory, it's a non-volatile memory. It means it retains its data even if you power off your device. Data is always stored there because these data will allow you to bootstrap the computer. يبدأ من جزئية معينة موجودة في الROM, okay, and primarily used to store firmware of an embedded device. So in order to start this Arduino, it will first boot from the bootloader located in the ROM, and then it will start the other programs, okay, that will put inside. So the key features in ROM: it's non-volatile, data is preserved without power, and it's used for firmware storage. In microcontroller, so we use an internal flash memory for faster access to hold application code and bootloader. And the microprocessor like Raspberry Pi, we can use external storage, my external SD card, or we can use also SSD depending on the speed that you want to achieve on the performance. And the reprogramming, so flash ROM allows multiple write cycles, enabling update. طبعا if you have a firmware, sometimes you need to update it. والفirmware موجودين حتى لو تشتري مثلا ذيك مثل البين سبورت والاشياء من هذا يقول لك بعض الاحيان تستطيع تعمل تحديث. مثلا these are type of embedded devices that you need to update their firmware using the bootloader. طبعا this is a very critical operation. It's made only by experts. It's not like reinstalling the system, because you need to access directly into the ROM and then flash it and you replace the old code with an existing code. Okay, and it uses specific type of cabling to access the internal hardware of the ROM. So there are different type of ROMs. Flash memory, which are used in microcontroller. They can be erased or programmed, making it the firmware flexible for updates. And an example of the Arduino Uno. So usually when you upload your program, you'll put it in the firmware with a maximum of 32 kilobyte flash memory to store your program. So your program, this is the firmware of the microcontroller, which will be loaded by the bootloader. And this allows multiple uploads and updates of sketches or scripts, Arduino scripts. So the EEPROM, so basically it's another type that we can use also to store user data like preferences or setting. So this is for bootloading, and the EEPROM, it's used to store small amount of data that must persist across power cycle, like for example Wi-Fi data, Wi-Fi credential, or sensor calibration data, instead of doing that every time with every update. So we can store it persistently into the EEPROM. And in microprocessors like Raspberry Pi, we use external storage as a ROM, like a micro SD card or an SSD hard drive. This is from where it will boot. So we'll not make small memories, because usually this type of memories will be small in size. So we cannot store Ubuntu operating system or Linux operating system onto EEPROM or flash memory. So we store it on external storage, like an SSD hard drive, SD cards, or eMMC modules. They are flexible to change and upgrade the OS firmware as needed. Okay, so this is a comparative table. I think we came to the end. The difference in terms between flash memory, EEPROM, and external ROM. The internal flash memory. The type here in flash memory, we use an internal flash memory. Here we use an internal EEPROM, and here we use an external storage. The size, usually it's small, so this can go to 32 to 250 kilobyte per second. It can even be at 12 megabyte. So the EEPROM is even smaller because it's only used for storing byte level updates like the user data preferences. And this usually goes to very high capacity, up to 1 tera or even 4 terabytes for storage, the external hard drives. So all of them are reprogrammable. This has limited write cycles. And the purpose is, this one is for firmware and bootloader, the EEPROM for persistent user data, and the external ROM is for firmware and OS, operating system storage. Okay, so that's it for today. We have 15 minutes.